Hi, I am Lopa Mudrashen. Welcome back to my channel, Electronic Science Tutorial. From today, I will start a new lecture series on NTA UGC NET and West Bengal SET exam for Electronic Science subject. Those who are not check out my channel, please follow my channel. If you like my channel, then please do like, share and subscribe my channel. So let's start our class. In today's class, we discuss about the NTA UGC NET and West Bengal SET exam 2022. In this session, we cover in detail about this topic so that we can easily solve the previous year question paper of UGC NET Electronic Science. Each and every topic we can understand in easy and simple manner. So, let's begin our NTA UGC NET exam 2022 class. Okay. Today I will discuss one most important topic of semiconductor device, that is electron effective mass. When an electron moves through a lattice structure, it faces many obstructions, but this electron when moved through a free space, it must be very smooth movement, because in the lattice structure a group of arranged atoms may obstruct the electron movement, right? Which is not possible when an electron moves through a free space. Okay. So there is must be different the movement of an electron in a lattice structure and the movement of an electron in free space, right? In the crystal structure, there are some internal force due to positively charged ions or protons and negatively charged electrons. And when we applied external force, the total motion of electrons in the lattice, we can write that is F total equal to F external plus F internal, that is equal to MA. What is M? What is A? We talk about this topic. So F total equal to F external plus F internal, where F total is the total force for external force which we applied externally, and internal force means crystal internal inbuilt force, that is the positively charged ions or protons and due to negatively charged electrons. So what is F external force? Externally applied force. What is F internal force? That is the crystal inbuilt force, that is equal to, that is due to for positively charged protons and ions and negatively charged electrons, and that is equal to m, that is the mass of the particle, and a, which is the acceleration. So this is the total force of an electron when it moves through a crystal lattice structure. It moves through its mass, and due some acceleration, it accelerates from one side to other side. So this is the total electron force into the crystal. So the total electron force is depends on F external, externally applied force, and F internal, its inbuilt crystal force due to positively charged ions or protons and negatively charged electrons, and that is equal to Ma. That means the total mass of the electron or the mass of the particle, and through which it accelerates from one point to another point. So this is the total force of electron in the crystal structure. Okay, so this is the basic fundamental of electron effective mass. It is difficult to take all the internal forces, so we can write the equation as F external equal to m star A. In previous equation we write that F internal plus F external equal to m star A, but all the internal forces are considered is so much difficult. So we replace the previous equation by this equation, that is F external equal to m star A, where A is the acceleration which is directly related to the external force and m star is the effective mass of the particle which taking the effect of internal forces also. So m star is called the effective mass. So this is the basic concept of effective mass. That means when an external field is applied to a semiconductor, the charge carrier, that is the electron, and the holes experience some forces due to the externally applied electric field and also due to the internal periodic field which is produced by the crystal. If the applied field is much weaker than the internal field, if the applied external field is much weaker than the internal field, the effect of the latter is to modify the mass of the carrier in such a way that the carrier respond only to the applied external field with the modified mass. Right? This modified mass or the modification of mass is known as the effective mass of the carrier, which is very important topic of semiconductor device. I hope you understand. When an external field is applied to a semiconductor device, the charge carrier, that means what is the charge carrier into the semiconductor device? That is the electrons and the holes. These electrons and holes experience some of the forces due to the externally applied field and also due to the internal periodic field which is produced by the crystal. What is the internal periodic field? In previous slide we talk about this topic, that is the internal periodic field means positively charged ions and protons and negatively charged electron force. So this is the internal periodic field. If the applied field is much weaker than the internal field which we applied externally, if this field is much weak than the internal crystal field, the effect of the latter is to modify the mass of the carrier. That means electrons and holes carrier, we have to modify this carrier in such a way that the carrier respond only to the applied external field with this modified mass. Okay, so this modification of mass is called effective mass. Right? So this is the basic concept of effective mass. I hope you understand. Thank you. I hope you love this informative session of NTA UGC NET or West Bengal SET exam. If you like my video then please do like, share and subscribe my channel. फिर मिलते हैं एक नई वीडियो के साथ. Thank you.